Namaskar, my dear friends. In our previous lecture, you were learn about the different methods to draw the involutes. Now, in this lecture, you are going to learn about the methods of drawing the spiral. Okay, so the spiral it is also part of the engineering curves. Now, let us understand first of all what is the spiral. So, spiral, if a line rotates in a plane about one of its ends, and if at the same time a point moves along the line continuously in one direction, the curves traced out by the moving point is called a spiral. Now, say for example, one line is there OA. Okay. Now, this line OA is moving about this point O, okay, in this direction. Now, at the same time, the point or any insect, suppose any insect is at point A. So when this line is moving in counterclockwise direction, at the same time, the insect on this point A, it will move towards the center O. So the path of that insect is called a spiral. So the point about which the line rotates is called the pole. So here, this point O on which this line is rotating is called the pole of this spiral, and the line joining any point on the curve with the pole is called a radius vector. The angle between the radius vector and the line in its initial position is called vectorial angle. Each complete revolution of the curve is termed as convolution. Okay, so the term convolution means the 360-degree rotation of this spiral. So here in case of the spiral, we are using the convolution. That means the one revolution is equal to one convolution and is equal to 360-degree. Now, classification of spirals. So there are three types of the spirals: Archimedean spiral, logarithmic spiral, and spiral for clock, semicircle, quarter, circle. Okay. So as per our syllabus is concerned, we have to learn only this Archimedean spiral. Now, how to draw the Archimedean spiral? Let us understand by one example. So, Archimedean spiral, it is a curve traced out by a point moving in such a way that its movement towards or away from the pole is uniform with the increase of vectorial angle from the starting line. That means, as discussed in our first slide, when the insect is moving towards the pole or from away from the pole, so its movement is uniform. Okay, so this curve is known as a Archimedean spiral. What are the uses of this Archimedean spiral? The teeth profile of helical gears and profile of cams. So there are number of uses of this spiral curve. Okay. Now one problem: to construct an Archimedean spiral of one convolution given the radial movement of the point P during one convolution as 60 mm and the initial position of P is the farthest point on the line of free end of the line. Okay, so we have to construct here the Archimedean spiral for one convolution. That means for one revolution, or we can say 360-degree revolution. Okay, and the distance is 60 mm. So greatest radius of this spiral is 60 mm and shortest radius means the minimum radius is 0 mm. Okay, so at the center or at the pole. So now first of all, take O as a center and radius equal to 60 mm and draw one circle. Now divide this circle into the 12 division. You can divide also in 8 division, but here we are dividing this circle into the 12 equal division. Okay, and it is rotating in counterclockwise direction. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Okay, so initially point P is here, and during the one complete convolution, the point initially at here, it will reach at this center, at the pole, and this distance is 60 mm. Okay, so now divide this distance O0 into the 12 equal division. So one part is of 5 mm. So name the 0, 1 up to the 12. Okay, so here we divide the circle into 12 division. So that's why we have to divide this line into the 12 equal division. Okay, now if this point moves 1/12 of the revolution at that time, okay, this point will be on this line. So for that, first of all, now take O as a center and radius equal to O1 and draw arc up to this line O1. Okay, so the intersection point is P1. Now similarly, this O as a center, radius equal to O2 and draw arc up to the line O2, and this intersection point is P2. Now similarly, O as a center, radius equal to O3 and draw arc up to this line O3, and intersection point is P3. Similarly, you can find all the points P1, P2, P3 to P12. Yeah, so point P4 is on this line. Similarly, you can find the point P5. Now O as a center, radius equal to O6, and you will get the point P6. O as a center, radius equal to O7, you will get the point P7. Similarly, find the point P8, P9, P10, P11, and finally P12 point is at center. Now join all these points by a smooth curve. So this curve is known as a Archimedean spiral. Okay. Now let us understand by one more example. To construct an Archimedean spiral of one convolution given the greatest and shortest or the minimum radius, or to construct an Archimedean spiral of one convolution given the largest radius vector and smallest radius vector. So here the greatest or the largest radius is 100 mm and shortest radius is 60 mm. Okay. So now here we have to draw the spiral by using this data. So first of all, take center point O and draw one circle of radius equal to 100 mm, okay, maximum radius, and draw another circle which radius is 60 mm, or we can say R minimum. Now divide this circle into the 12 division. Point 1, 2, 3 up to the 12. Okay, so initially point P is at here. Okay, so after the one complete revolution, the point will be reached at this point. Okay, so now we have to divide this distance into the 12 division. Okay, and this distance is equal to 40 mm because 100 minus 60 is equal to 40. So divide this distance into the 12 division. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and finally 12. Okay. Now this O as a center and radius equal to O1 and draw a circle up to the line O1. So this intersection point is P1. Now O as the center, radius O2, and draw a circle. You will get the point P2. Similarly, get another point P3, P4, P5, P6, P7, P8, P9, P10, P11, and finally P12. Join all these points from starting P0 to P12 by a smooth curve. Okay, so this curve is known as a spiral. Now we have to find the constant of the curve. So how to find out the constant of this curve? So the constant, it is the ratio of in length or any two radius vector to the angle between them in radian. Okay, so is equal to this difference in length of any two radius vector. That means take OP minus OP3 here. Okay, difference between the length of any two radius vector. This radius vector is OP and here OP3 upon angle between them. So angle between these two radius vector is pi by 2. Okay, so length of OP is 100 mm and we have to measure this length OP3 is equal to 90 mm. So the constant of this curve is equal to 6.37 millimeter. Okay, so now draw a circle of this radius equal to 6.37 millimeter. Okay, and if you draw the tangent from this, then this is the normal of the curve, okay, which is passing from point S, and a perpendicular line which is to this normal is called a tangent. Okay. Now spiral of two convolution. So point P is 80 mm from point O. It starts moving towards O and it reaches in it 2 revolution around. Draw locus of point P. So here it completes the to reach at that point, it completes the 2 convolution or the 2 revolution. Okay. So find total angular and total linear displacement and divide both into the same number of equal parts. The different steps are given here. Okay, so total angular displacement here is 2 revolution and total linear displacement here is distance PO. Okay, so just divide both in same parts, that is the circle in 8 parts. Here we are dividing the circle into the 8 parts. Okay, so that means the total angular displacement in 16 parts. So divide PO also in 16 parts. Okay, so first of all we have draw a circle. Okay, now divide this circle into the 8 division, right? And this radius is equal to 80 mm. Okay, so point 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so it completes this distance by 2 convolutions. So again 9, 10, 11, 12, 13, 14, 15, and 16. Okay, and divide this line into the 16 division, right? So initially point P will be here. So 1, 2, 3 to the 16. Now remaining step remains same as earlier. This O as a center, radius equal to O1, and draw arc. You will get the point P1 here. Similarly, now O2 radius, O center, and draw arc. Similarly, O3, and you will find the different points. So point P1 will be here, P2, P3, P4, P5, P6, P7, P8, P9, P10, P11, 12, 13, 14, 15, 16. Okay. Now join all this point by a smooth curve. So it is known as the spiral of true convolution. Different points are there here. Now, one more problem. A slotted link shown in figure rotates in the horizontal plane about a fixed point O. While a block is free to slide in the slot, if the center point P of the block moves from A to B during one revolution of the link, draw the locus of point P. Okay, now here one link is that OAB and it is rotated about this point O. At that time the slider P is in between this A and B and it is moving. Okay, so draw the locus of point P. Now distance between O and A is 25 mm and A and B is 40 mm. Okay, so you can see here the link O as a center, this distance is 25 mm. OAB. Now first of all draw a circle of radius 25 mm and another circle of radius 40 plus 25, that means the 65 mm. Now divide this circle into the 12 division. Okay, 1, 1, 2, 3, 4 up to 12. Right? Now divide this distance AB into the 12 division. Now this O as the center, radius equal to O1 and draw arc. So you will get the point P1. Now O as the center, O2 radius and you will get the point P2. Similarly, O center, radius O3, P3 point, P4, P5, P6, P7, P8, P9, P10, P11 and finally you will get the point P12. So join all these points by a smooth curve. So this curve shows the path of point P and it is known as a spiral. Okay, so now I hope you can understand very well how to draw the spiral. Okay, so thank you very much.